crane A can unload a ship in 10 hours. Those are those big red things. Crane B can unload it in 14 hours. It's a little bit slower. Crane A started to unload at noon and was joined by crane B at 2 hours later, right? At what time was the unloading job of the ship completed? Now, do you recall me saying that, and I used this to help, rate multiplied by time is equal to distance? Okay, well, we're very similarly going to translate all of this into rate of work, and that's the ability of the machine. Okay, so one machine can do it at this rate, the other machine can do it at a different rate. Multiplied by the time involved equals, instead of distance, the completed job. Okay? The rate of work multiplied by the time involved equals the job that's complete, equals the job being completed. Okay? So who am I comparing? I am comparing crane A with crane B, right? Now, the rate at which these jobs are being done is stated in sort of a weird way. Crane A can unload a container in 10 hours, okay? Which means crane A's rate is 1/10 of the job per hour, right? Hour 1, he gets 1/10 done. The second hour, now he's up to 2/10. 10 hours later, he has completed the job, whatever it is. We're unloading a steamship here, okay? This is a key thing for you to understand. If they tell you something takes X amount of hours, then each hour he does one fraction of that, okay? Whatever the hour-long process was. Crane B, on the other hand, takes 14 hours. So each hour is 1/14, okay? Time involved. Crane A started to unload at noon and was joined by B 2 hours later. So to translate this, I'm going to say crane B had 2 hours less worth of time than crane A. Would you agree with me based on their definition? So how do I multiply this out? Well, keep in mind that you're going to throw a 1 under both of these things, okay? So crane A's effort to get the job done is a product of the rate and the time, which becomes T over 10. Okay? Crane B's efforts to contribute to the job becomes T minus 2 over 14. Okay? 1 times T minus 2 numerator, 14 times 1 denominator. But what is the end result? Okay, if I add these two things together, T10 plus T minus 2, 14, what does it equal? Here's where it gets a little strange. It equals 1, because I am looking for the completion of a job. This is unloading a ship. Okay? So he does this much work, she does that much work to move something, whatever. How long does it take based on their strength? This is all about strength, right? Ability for those cranes. It's one job being accomplished. The job is unloading the vessel. Okay? From here, I'm pretty sure that you guys don't have any sort of concern about how to make this happen. But we'll go ahead and continue with it anyway. What you learned about the other day was to clear the fractions by multiplying everything by the lowest common denominator. Okay? The book already tells us it's 70 Easy peasy, right? So when I cross cancel here, I end up with 7t. When I cross cancel here, I end up with the product of 5 and t minus 2. Would you agree with me? This into this is 5. So I'm going to go ahead and do 5t minus 10. Just real quick, distribute it. All of that equals, nothing cross cancels. Okay, from here it's simple algebra. Divide, and t becomes 20/3, which is 6 and 2/3. Well, what on earth does that mean? Well, the time was 6 and 2/3 hours after the beginning. And the beginning of the job was noon, right? You always, when you're adding time to find a new time, you always start with the beginning, okay? The beginning. So noon plus 6 hours, 40 minutes, obviously is going to be 6:40 p.m. Okay? Rate times time equals completion of a job. Okay? Vehicles are completing a job when they're making a distance, right? You just don't think of it that way. All right. Bottom paragraph. This applies to the next page, so I want you all to look it over real quick. 8th grade, 7th grade. Percent is always out of 100, so when they give you percent value, you have to convert it to a decimal or a fraction in order to be able to solve whatever it is you're working on, right? 60% of something, 6/10 of the number will give you whatever it is you're searching for, okay? Use that all the time in life. Turn the page. Example 4. Do you guys get all this? Can I flip it? Okay. A nurse wishes to obtain 800 milliliters of a 7% solution of boric acid by starting with her 4% bottle and combining it to some degree with her 12% bottle. How much of each does she require? Okay. How much of each does she require? All right. I'm going to go ahead and write it out my way. It's pretty similar to how they do it. Okay, so the total amount, my friends, is 800, right? This is what the nurse is seeking. She's seeking to create 800 milliliters, which means the total of these two things somehow have to become 800, okay? When you have two things equaling something, you call one X and the other the total minus the original number, the other one, okay? You could do it either way. I'm just doing it the book method. So X milliliters at 0.04 for 4%, and 800 minus X milliliters of 12% is going to somehow combine to create this 7% value. I'm just writing that there. All right? So this times this, so 400ths X added to this times this has to equal 7% of that, right? So Y'all with me so far? I know this is kind of weird, all right? Multiply number of milliliters times the percentage of acidity. Percentage of acidity, number of milliliters. Percentage of acidity, number of milliliters. Okay? Combine the 4% with the 12% and somehow get this. All right. You might not like working with these big honking decimals. Since they are both in the hundredths, if you multiply every single piece by 100, you can convert and get 4x plus 12, 800 minus x. I haven't obviously done that yet. And 7, 800. Okay, does everybody see how I converted by simply renaming? Okay, this is like renaming fractions, people, only we're renaming decimals. All right? So, now we simply have to solve it algebraically, carrying our 12 over, getting our 9600, minus 12x, forgot to put my 4x up there, and all of that should equal 5600. By the way, if you don't want to do this because to you it just seems sketchy, don't do it. Just leave it. You can still solve it as decimals. It's not a big deal. Okay? Alright. So now I can combine my like terms, which is going to give me a negative, if I can do my math here, 8x. And I'm going to subtract my 9600. Okay, so I combined these, subtract 9600. The book does the answer for you. Obviously that equals a negative 4,000. So now you're thinking, well, what kind of answer am I going to come up with? Well, thankfully, a negative by a negative will give you a positive, right? So after the division, you should have come up with 500, right? But where does the 500 go? Go back to your chart and see what you identified as x. Okay? That means 4% has to be 500 milliliters. And 12% has to be 300 milliliters, right? For a grand total of 800 milliliters using the mixing described. Okay? All right. The last one I want to do with you guys. Unfortunately, it's not in your book. Okay, so I'm going to turn the page. I'm going to put it on here so you all can see it. And then later you can look back at it. All right. There we go. Nice and small. I'm going to zoom it. Give me a second here. Give you a chance to kind of look it over. Okay. Since I can't zoom, I'm going to go ahead and read it to you. The German club collected the same amount from each member participating in a trip to a music festival. When 6 could not attend, each of the remaining members had to get charged $2 more to cover the total cost of $360. How many actually went? Okay? How many actually went? Okay. So, we've got two scenarios going on. We've got
Harley and Hunter, please come to the office.
We've got M describing the members that went. And we've got M plus 6 describing the original amount, right? Because 6 of them didn't go. You could also take it and say n minus 6 went, and m was the original. N minus 6 went, okay? But we're going to do, this is the group that went, okay? This is the original, okay? 6 more we're supposed to go, okay? So the total cost involved, cost times count of people will give you the total cost involved, right? That'll give you the total cost involved. Okay, so if you take that total cost and you think about how that total cost got distributed, that total cost was only distributed over the people that went. Okay? That was only distributed over the people that went. Alright? This is a tricky one. Okay? So, what it should have been, however, was this. Okay? This is how it should have been. This is how it ended up. So this added to the $2, okay, gave us that. Okay? How it should have been, how it ended up, add $2. Okay? Now, greatest common factor. This is a hard one, so don't worry. I'm not even sure if we'll get to one like this, but I just wanted to expose it to you anyway. Now, greatest common factor is what? m plus 6. Okay? So, m plus 6 here, m plus 6 here, m plus 6 here. All of that's over 1, right? And it'll cancel some stuff off. So you're thinking to yourself, well, what did adding 2 have to do with it? Well, it was $2 per person, and it's going to be distributed in here once I multiply it. So, first position, 360m. Second position, 2 times m plus 6, okay? 2 times m plus 6. Final position, 360 times m plus 6. Okay, lots of algebraic work that has to get done here. This one we can ignore for now. So, 2m squared plus 12m. Keeping that in play. Trying to see, did I make a multiplication error somewhere? Hold on, I'm just checking my notes. 2m squared is only 360m. Hang on a second. Hang on, stand by. Right here. 6. This got distributed to, I did that. 360m plus 6 equals 360m. That times that. Thank you. Okay. Equals 3, I forgot to cancel, I multiplied it in. 360m plus whatever 6 times 360 is, and for sake of time, let's get my calculator out really quick. Sorry about that. 360 times 6, 2160. Okay. Whew. Okay, forgot to cancel my m's, and I left it in there. Okay, so now that I've distributed here and here, I can start moving everything around. You could probably see that these 360s are going to cancel each other out, because if I subtract this to here or this to there, either way it's going to cancel out. Okay? If I subtract my 2160 over, I now have 2m squared plus 12m minus 2160, all of that equaling 0. Before we try and factor, let's look for a greatest common factor, which is 2. M squared plus 6m minus 1080. Okay, now comes the factoring challenge. Factors of negative 1080, that one added together gives me a 6. And for sake of argument, I actually already have it here. M plus 36 and m minus 30. So the amount of members is either negative 36 members or the amount of members is 30. You got to throw out the negative 36 because clearly you can't have a negative number of people participating. Okay?